Okay, so after you replace your battery, you're going to go over to your battery backup setup here on the function. And once you're in here, it's going to be battery not installed. So you're going to want to turn that on. And then the SC203 bit will automatically turn on. And then you'll set your battery replacement notification for, it looks like 5 years is what they automatically set after. Click OK. You have some bits that you can use, like if your SC28, if your battery's low, it'll it'll give you like an error, and then you can use that bit to inform you for to replace it. And then of course you have your SC28 when it's off, which is showing that the battery voltage is good, meaning it's not low. Click OK on that. Then you go to calendar clock adjustments, and then you'll adjust the PC clock. So in my case, I'm just going to adjust to the PC clock, which is today's date, and then write to PLC. And then after that, you want to write your project into PLC so that you can so that the changes that you put inside the backup battery setup will be placed into the PLC. So after this, the thing is why you need a battery in order to ensure that your date time functions properly is because if you don't have a battery inside your PLC, then every time that you cycle power on it, or you have a power loss of any sort, then it defaults the date time back to like 2000, it's like 000 and then 2000. It's basically starting from a default value rather than your today's date. So then all your code that you're relying upon today's date doesn't work because it has defaulted back to a base value that is not today. Then you're going to have to constantly go back in calendar, go to adjust the PC clock, and then write to PLC. So you're going to have to constantly do that after every power cycle if you don't have a battery. So that's why we want a battery. So after you do that, then you'll, as you can see here, the battery installed, so the bit turns on. And then I just have an instruction here that has SD24 because if you go to your instruction list, program, address picker, and then you have SD24, it says RTC hour, SD25 is RTC minute. So this is actually giving you the current values of the current time. So hour is 7, as you can see, it's 7:51 a.m. And then if I had minutes here as well, these are integer values. That's why I use just this compare logic, because you can see the integer value. And this is, I'm just testing right now. So if I put minute there, then it would be 52 minutes. And then seconds, of course, will be the second. So this is how you'll basically have your timer set so that you can you can make sure your ozone is turning on for 2 hours in the evening is what's pretty common. And then you have it turn off so that you can set the time for whenever in the AM that you want to turn on the ozone, and it will just cycle through this continuously. And through a power cycle, it will maintain that same clock settings that you have so that it consistently does it, at 2 a.m. if that's what you set it from 2 to 4 a.m. So I'll be going over more detail specifically on how to write the code out for Ozone, and I'll give you guys more details on that. Here's just a teaser right now. So this is just a C3, so all the C bits are just bits that you can use, internal bits. As you can see, the pump has to be on in order for the ozone to turn on. And then once the ozone turns on, it latches in here. And then after and it latches in here until the 2 hour ozone timer goes off. So here's the timer that I have that starts right when the ozone turns on. And after 2 hours, which is 120 minutes, then it turns this bit off, which actually unlatches this rung here and then turns off your ozone. So we have our timer set, and then we're going to add some code over here to turn it on. Instead of C3, we're going to add some code to turn it on from 2 a.m. That's when we'll turn it on. So we can go based off this hour marker that we have here now since we got the battery installed.